Hello, everyone. Welcome to another Open Cluster Management Community Meetings. Today is 2025, November 21st. On the agenda today, we have Su Chao going to talk about privacy preserving an efficient AI model training across multi-cluster. And then afterwards, Quinn Hao and Kijun is going to talk a little bit about the add-on API. Su Chao, will you be sharing the screen? If you are, feel free to take it away.
I'm sorry, I thought I listed my topic to December.
Yes.
Oh, Chicha. Oh, sorry. Yes, I misheard my name. Sorry. Sorry about that.
No, it's all good. Xu Chao, yes. So
Okay,
whenever you're
okay,
ready,
I
feel
will
free
share my
to.
screen.
Yeah.
是什么？Uh, can you see my screen?
Yes, we can.
Oh, okay. Then I start. Uh, Hello, everyone. I'm Zhichang. This year, I participated in Google Summer of Code 25, and under the guidance of my mentors Meng Yan and Qing Hao, I'm very grateful for their help and support through the project. I worked on the project privacy preserving and efficient AI model training across multi-clusters. Today, I'd like to share what I accomplished during this project. I mainly did three things, and the first is enable the federated learning observability, and the second is support the OpenFL framework, and the last thing is enable the model persistence in the AWS S3. And because the whole process will takes a long time, so I recorded a video in advance. Let me show the video and mm, the first video is the Flower framework and the OBS environment setup. The first step is to set up the local kind environment. This will take a long time, so I will fast forward. And now the two managed clusters have been set up. Then I will follow the document. The document is here. All the things is in our repo, and we can find here. This is a step-by-step document, and we can copy the command and set up the local cluster and set up the Prometheus and open telemetry and the Kepler and all the things here. Okay, then we can still we will need it. The federated learning cluster. So we have to register it and to get the metrics from it. Okay, the hub cluster has been registered and as the local cluster. Then I will deploy the Prometheus and the open telemetry environment. Okay, all the observability environment has been set up, and after this, I will build the flower image and run it. And each training round, we can get the application level metrics and all the system level metrics. All the pod is running. We can build the flower application image easily and using this makepad. I use the registry of Aliyun because it's faster. And this is the and now I will install and run the federated learning controller. Oh yes, the KC is the alias of the Kube control. It's just for easy to use. Uh, Now the controller has started and the federated learning resource has been applied. And now I will apply the cluster 1 and cluster 2's cluster claim and select the placement to choose the. This is for cluster 1. Okay, now we can see the controller had selected 2 clusters for the model training. And because this will download a lot of Python packages and it will take a long time. Now let me see the system level metrics. Here is all the metrics from the Prometheus. Currently, there's no application level metrics because the federated the learning has not been started yet. This is the Kepler metric, and it's from the cluster 1, cluster 2, and the local cluster. It is still install the package. It's a little bit slow. I can fast forward. Now the training has started, and the round one is has been started. Wait for a moment, and when there's the round two, it shows that the round one has been done. And currently, the application level is still empty. Please wait. My CPU runs at a full load. It is training now. Now here's the round two. And now here's the round two, and we can get the application level metrics of the round one. And now these metrics are piracy, and it's from the class one, cluster two, and the local cluster. And the round tag is one. And this is the loss metric. The round two has been done. We can get the auto metrics of round one and round two. We can designate, we can distinguish it from the round tag. This is round one, and the below is round two. Yes. Now the three rounds are all done, and we can get all the system and the application level metrics here. And now I delete the federated learning resource. And this is the first video. The other two things is it support the OpenFL framework, and the document is here. And the last thing is to enable the AWS S3 to persistent store the models. And the two and the second video will show them. And this video will build the OpenFL image and set up the AWS S3 environment. And this step is still set up the local environment. The first step is to set up the AWS. The key ID and the access key have hidden. Just apply it and install the AWS S3 CSI driver. Scanner is creating. Please wait. Both are running. Now I will build the OpenFL image. The build step is similar to the Laravel framework. I will save to my registry. Let's see the federated learning resource. It only change the framework open to OpenFL and change the storage type to the S3 bucket. And also the image name, because we are using the OpenFL framework. And I checked the AWS bucket, and now it is empty. After training, there will be the trained models. So let's start. And this step is to apply the cluster claim for cluster 1, cluster 2. Now install and run the federated learning controller. OpenFL's image is also is really big. It will take a long time to download the image. and now the code is running. And currently, the AWS bucket is still empty. After the round done, there will be 2 models built in it. Oh, OpenFL's one round is fast, and just now it has finished the first round, and now we will see the AWS bucket. There's 2 model built, and the time is just now is 10:07. Okay, that's all. Thanks for listening. Is there any question?
Yeah, I have a question about the matrix mostly. So the first one is about can we know the time spent on each stage so that it is possible to optimize. For example, I see that there is time to downloading to install the library, to download the base model, etc., and training and parameter aggregate at the last stage. So it is possible that framework or somehow we can provide some kind of time spent during each training.
Yes, we can get it because the application level are defined here. Let me show the code. This is the flower application. And each round we will write the matrix to a field. It will write the matrix here. And if you want to if you want to see the time span, and you can just write it to the matrix field. Here we only write the loss and the currency matrix.
Okay, but for the part that hadn't been started, we need how do we know that? Like when we start the container at the first time, it need to install a set of library initially.
Oh, you mean that in the initially that time and set up the packages? Yeah, right.
Yes.
Yeah, we don't collect such metrics like download timing, how it spent. But the metrics is only about the platform like metrics like the CPU memory power consumption during the training process, and also the model metrics like accuracy, loss value. But we don't collect the time, like how much time it spent to download those libraries. Yeah.
Okay. So another question is about the relevance between different matrix. How are we going to relate them? Because we have matrix from Kepler, there are matrix from the applications. are we going to just use the time step and Paul name to correlate them, or is there any other thing that we want to use?
Okay. First, we use the OpenTelemetry collector to collect the CPU memory, which can collect those metrics. But also, I think we start a sidebar to collect the metrics like the application level, like the loss value accuracy of the models. Yeah. And Shitao, you can add more detailed information about my description. Okay. And also, uh, besides this project, I have using another way. When training the model, we printed this application level metrics in the log, and I use the AI model to collect these logs to extract these metrics. This is another way, but we provide a more robust way is a sidecar to um, to watch some metrics files that the sidecar to export these metrics into that file. Yeah, yeah, that's is my expression clear?
Yeah, I think so. I think I understand the matrix that we collect. So what I wonder is some use case like I think we want to know, for example, during this training, how much power has been consumed, during a certain training, how many resources is consumed, which brings to the how much cost is brought in in a certain cloud. I'm just thinking I understand that we have like to already collect many metrics. I just want to understand to think I'm thinking how that matrix finally help us to know things like power consumptions per training or like cost per training. That's yeah, that's something I haven't been quite clear about that.
Okay. Yeah, I can share my screen to bring some scenarios how we use this matrix and okay, let's
I
begin.
will stop my screen share.
Okay. Here. Can you see my screen?
Yes.
Here. It help to analyze. Okay. This is the AI demo that AIOps using the metrics Shitao just introduced. And here I start a federated learning.
Sorry, you might not be sharing the correct screen. Maybe you have multiple monitors.
Okay.
Yep, we're looking at a query.python py.
Well, oh, not let me try to. Is that right?
Yes, we can see the web server now.
Okay, I built a AIOps agent that uses the metrics Shitao just collected. And this is to create a federated learning, and just as he showed. And after that, we did some analyze based on that matrix. Like I want to get the memory usage of each instance of the federated learning. So we can see here it retrieval this matrix from the Prometheus and sorry, it not jumped. And we can see the CPU change. This is just an instance. When it's running, we get the instance matrix, but we also can get some range matrix. How those this is like the memory changes, that will help us to understand which model, which Clint model with more CPU usage and power usage to let us define, okay, there may be have more data for training, and I think I have some conclusion in the before, but it's a long time, so let's just jump to okay, maybe this is power consumption. Okay, let's look at this. We can our goal is to let each client work properly, and for this scenario, we can see both the client with almost the same power consumption. That means these two clients work with almost same workload, but also we have some others, I think. Oh. Here is some, I think. Yeah. This is a matrix I have do before that with each round we can see the accuracy change, and like I don't find the right diagram, but I remember that is that with each round we have collect the accuracy and the loss value, and after several rounds we find that the accuracy is not improved, so we can use that matrix to define the correct round for the training process. Yeah, I think there are this matrix can help us to define the hyperparameters of those model training, or how we define the model. Yeah. It's just in such case, I just thought, but I think for the more matrix you want to observed, you can get more interesting idea about it. Okay, that's is that answer your question, Qiujian?
Yeah, I think so. I think sort of like I can see the value there. Yeah, I think this is a great demo. Thank you.
Okay, thank you. And
That was great. Thank you.
okay.
Anyone else have any comments, questions? If not, thank you again for the great demo. Quinn, how do you want to share your screen, or is it Qiujian that's going to talk about the add-on API?
I think I will first introduce about our Beta 1 design, and Qiujian will introduce more for the registration part. Okay, let me share my screen. Okay, today I want to share is our new V1 Beta 1 design, and I will introduce first. Next, Qiujian will introduce for the registration part. We have a issue in the community is we want to move our a cluster management add-on and manage cluster add-on API to V1 Beta 1. So as a first step, we want to introduce the Beta 1 API based on the license we learned from Alpha 1. So there are some changes and some field will be removed. Let me show you the change. So the motivation is we have some accumulated deprecated field from Alpha 1, and also some field need to be refined based on the community's feedback. So all these changes will be addressed in V1 Beta 1. The main change include 4 parts. First is some deprecated field will be removed. And next, for the add-on configuration part, the supported config will be renamed to default config. And the registration part, there will be a more fine-designed registration API, so it will be more flexible for the future add-on registration pattern. And last is the V1 Beta 1 API design will maintain the backward compatibility with the Alpha 1. Okay, next let me start from the details. First, the change is in the Alpha 1 in CMA, we can define the supported we can define the default config inside the supported config. But since today the supported config is actually hard-coded in the add-on framework, so this field will be changed in Beta 1. In Beta 1, you can directly define the default field in CMA.spect. And for the default config, the resource, it's a map, it's an array, and for each atom, the key is the group and the resource. That means for default config, it does not support defining multiple default configs with the same GV key. Let me show you an example. Another is for the conversion webhook. So to keep backward compatibility, there will be a conversion webhook to convert the supported config to default config. And since the default config, default config is an optional field in Alpha 1, so a placeholder will be used as a reserved name when we convert Beta 1 to Alpha 1, but there is no resource name defined. There are 2 examples. The first example is user only define the supported config, but not define the default config in Alpha 1. When we convert it to Beta 1, you can see the default config group resource are mapped to Beta 1, and the name is a placeholder. And when it revert back, it will still keep the same as what you defined in Alpha 1. A second example is user defined both the supported config and default config in Alpha 1. The conversion webhook will convert it to the format in Beta 1, and it can also convert it back to Alpha 1. All the values will be kept. This is the first change for the default config. Next, for the registration part, I will leave it to Qiujian to introduce more for this. And the third is install namespace. In Alpha 1, user can define install namespace in managed cluster add-on. And this field is already marked as deprecated, and it will be removed in Beta 1. There will also be a conversion webhook to convert it. If you define your install namespace in Alpha 1, it will be converted to annotation in Beta 1. Below is an example. In Alpha 1, for example, user can define the install namespace here. And in Beta 1, since this field is removed, the conversion webhook will store it in an annotation. So when it convert back, the value is still here. Okay, this install namespace. The last is for the config reference in the status. Today we have some duplicated field in manage cluster add-on status. For example, the config reference .name and namespace are actually duplicated with the desired config's name and namespace. So these two fields will be removed in beta 1. And a conversion webhook will convert alpha 1's field to beta 1. Let's say an example. This is an example of alpha 1. There are actually desired field define the name and spy hash. And the last applied config also define the name and spy hash. And outside of it, there is also a name and a resource and a group name. But in beta 1, the config reference .name is actually removed. So the info is actually still stored in desired config and the last applied config. And when it revert back, we will still set this value for you. Yeah, this is the change for the status. And last are some fields will be removed. These are some labels and annotations. The first field to remove is in CMA, the spec.addon configuration and MC also have a status.addon configuration. These two fields will be removed since no one is using them, and we will not provide a conversion webhook for it. And below are some annotations and labels which will be removed. All these today have a new value you can use instead. And I won't list them one by one. You can check this doc for more details. Yeah, I think that's all for the change in beta 1. Please let us know if you have any concerns for this or any more feedback. Next, I want Qiujian to introduce more for the registration part. Qiujian, do you want to share your screen? Or
Yeah,
just-
okay.
Okay, I will stop share.
Yeah, let me share my screen. So we want to enhance especially the registration part in the managed cluster add-on in beta. The main issue that we want to resolve is the EKS issue, like we cannot register add-on in EKS environment, but also in some other environment because of CSR is not supported for the kube client. This also could help. So previously we assumed that all the registration, including add-on and the classlet, is based on CSR. So if there is an environment that doesn't support kube client-based CSR, the add-on cannot be supported. In managed cluster add-on beta API, we will try to use different API. So in the registration field, previously there is no type. It's only signer name, and you can define whether it's kube client signer or other signer. But we will include a type. We want to include a type. So with that type, you can define whether it's a kube client-based registration, which means that add-on will go into is going to connect to the Hub API server, or it's a CSR-based registration. So it's not supposed to connect to the Hub API server, but probably another endpoint on the Hub. but still need the MTLS. And in the group client based registration, we can like to configure the user groups, and also the driver of the classlet that can support to register to the group client. So I think that one of the reason that not only the API but above the API is we want to separate the registration mechanism between add-on and the classlet, which means that classlet can use a registration driver with ISRA, and then but the add-on can use another different registration driver like token. So that helps us in the EKS. So for example, in EKS, we could support that the classlet is using ISRA to register to register a cluster, but after that, if there are some limitation that add-on cannot use ISRA, they can choose to use we can let user to configure the classlet to use token as a token-based way to register add-on. So in addition to that, we also will need to create a add-on driver field in the classlet API, so these two will be separated. Like you can select the registration driver to register the cluster, and then the user also need to configure the add-on driver to connect to use for the add-on. So there's some idea how, so it's not quite done yet, but there's some question like how we use AWS SRA to register an add-on. I'm not quite sure about that, so I still need to investigate. And whether we want to introduce another token driver, like for example, we could create a service account for each add-on in their class namespace with a certain name. And then we let the registration agent to request a token for the add-on and create a kube config for this add-on. So then the agent is responsible to tell that this add-on is registered with this subject, right? Like the service account based user and group. And then the add-on framework is able to set up permission based on that. So that's a rough idea. I haven't thought thoroughly about that, but I think that could be possible as a trade-off when the add-on cannot use CSR-based registration. Yeah, I think that's all. Any questions?
So I have to define where do I define the driver in the add-on? Like this is the status. Do I?
Yes. So this is actually decided by the classlet agent. In the classlet agent, you'll need to configure that this agent is going to use, for example, token as add-on driver. And then the classlet agent will update the status of that part, telling that this driver is using token-based driver.
But the clusterlet is a singleton. But I have multiple different add-on. Like some add-on I need to use the CSR. Some other add-on I would like to use the hub client. I mean the hub. How would I do that?
Yeah, so this one is only for kube client based, right? So for CSR, we don't even have a problem. Like you
Oh,
can use it in any kube cluster. The main thing is about the kube client.
thank you. I see. I see.
Hi, Julian. I think maybe we can introduce some new conditions to reflect the add-on registration progress.
Yes. Yes, I think so. Yeah, we can add that in this doc, and then we can make it into a proposal. Okay. If there's no questions, I'm going to stop sharing.
Thank you, Kujan. Thank you, Cornell. We're a little bit over, but does anyone else have any question? Young, do you have any things you want to bring up? August,
No.
anything? Okay.
No, nothing on my side.
Okay.
Nothing from me, Mike. But I'm just curious. How was KubeCon for those who went? I didn't make it, but I don't know. Was it? If no one made it, then don't answer. But yeah, just curious if anyone was there in Atlanta.
I heard it was great because the OCM booth was super busy. Like there was almost like a lineup. So Gus, who was our representative, was almost like a celebrity. People were lining up, and then he was taking pictures of them. I think Young was one of them. Young is also another celebrity. Okay, so
Yeah, I was there. Like, there are many people, and yeah, I met multiple people. So multiple people are interested in the multi-clusters solutions, and yeah, and yeah, it was successful, I think.
Wonderful, cool. Yeah, no, I just wanted to sort of touch in, and that was it. Yeah, looking forward to Amsterdam.
great.
Cool.
Okay, thank you everyone for joining this week. See you all next time. Take care, everyone.
Thank you.